Hello, this is
Drumline,
Kevin Zhang.
and Joey Beskin.
Today we are presenting Physics in Everyday Life, Drumline edition. We will cover the concepts of rotational inertia, angular momentum, collisions, and more. When Kevin clicks his sticks, he uses the concepts of angular momentum and Newton's laws of motion. His right stick collides with his left stick, transferring momentum and setting it into rotational motion. An object in motion stays in motion, so the left stick spins until stopped by Kevin's right stick. Then he repeats the process until it gets tired.
In this demonstration, Joey performs a simple half-turn stick flip with his left hand while laying down a beat with his right hand. With his left hand, Joey exerts a downward force, causing the tip of the stick to rotate upwards. Joey then also applies another component force, making the stick rise in the positive y direction. Gravity then acts on the stick, pulling it to the level of his hand when the stick has completed its turn. As the stick is rotating, Joey catches the stick.
In this clip, Joey holds up two drumsticks in both hands. His hands each apply the same torque, resulting in an even velocity and spin around his thumbs. As the sticks spin around Joey's thumbs, the horizontal angular momentum stays constant. This system can be modeled as a rod rotating on a pivot point.
The stick is engineered so that its center of mass is at the center of the stick. The stick is rotated about the center of mass, which pivots on my thumb. We know that the moment of inertia for a rod or stick rotated about its center of mass is 1/12 ml squared. We know that the length of the drumstick is 0.4128 meters, and we use that to find the moment of inertia of the stick, which is 1.22 times 10 to the negative 3 kilograms times meters squared.
Kevin starts by putting his drumstick on his left wrist, using it as a pivot point. His right hand applies a constant torque, which is a cross product of radius and force. He applies a constant force, resulting in a continuous even rotational motion. The drumstick then hits the head and rebounds with a new rotational velocity omega.
The stick is thrown down at an initial height with an initial velocity. It hits the ground and rebounds up, ending at a height final higher than the initial height. We used the frames in the video to calculate the time it took for the stick to hit the ground and put this into the distance formula to solve for the initial velocity of the stick when thrown out of my hand. We calculated the initial velocity of the stick to be 8.57 meters per second. If we model the system as my hand, the stick, and the earth, we can state that energy is conserved. Therefore, the kinetic energy plus the potential due to gravity initial is equal to the kinetic final plus the potential due to gravity plus the energy lost due to the earth. The final kinetic energy is 0, and with this we can find the energy lost due to deformation, heat, and sound, and this delta E is equal to 3.77 joules.